Let's watch a block slide down a smooth ramp and see how its motion appears on two classic graphs. By the end you'll read position time and velocity time plots for constant acceleration motion. The ramp is friction-free, so the only acceleration comes from gravity pulling along the slope. That downslope acceleration equals g times the sine of the ramp angle and stays the same the whole ride. We place the origin at the block's starting point, so both position and velocity are 0 at time 0. On the left you see the block move. On the right two graphs trace its journey in real time. The top graph records position versus time. Because acceleration is constant, the curve is a parabola. Its equation is s equals 1/2 at squared, the result of integrating constant acceleration twice. The bottom graph shows velocity versus time. With constant acceleration this plot is a straight line. Its equation is versus equals a times t, the integral of constant acceleration once. Notice the two dots stay perfectly synchronized. Every instant the block's real motion matches both curves. At any moment the slope of the st graph gives the current velocity, while the slope of the vt graph gives the acceleration. When the clock reaches time capital T, the block has traveled a distance of 1/2 at squared and reaches velocity at t. For constant acceleration, position grows quadratically with time while velocity grows linearly. These two linked graphs give a complete picture of motion. The parabola tells where, the line tells how fast. Generate your own educational videos for free at eduvids.vercel.app.